This video is about the physiological concept of clearance and specifically hepatic clearance. Clearance can be defined either as the volume of blood totally cleared of drug per unit time, or it can be defined as the rate of drug excretion relative to the plasma drug concentration, which is the physiological definition and measures an organ's intrinsic capacity to remove drug from the blood. As we can see in this figure, an organ of elimination, like the liver or kidney, has blood with a relatively high drug concentration coming in, which is in the arterial blood, and then blood leaving with a lower concentration, which is the venous blood. The extraction ratio is a measure of how efficiently the drug is removed from the blood as it passes through the organ of elimination. We calculate the extraction ratio as the difference between the drug concentration in the artery entering the organ and the drug concentration in the vein that leaves the organ relative to the concentration in the artery. Notice that if the blood is completely cleared of drug, the concentration in the vein would be 0 and the extraction ratio would have a value of 1. Conversely, if the organ is quite inefficient at removing the drug, the venous concentration would still be quite high relative to the arterial concentration, and the extraction ratio would be low. With this definition, we can now calculate the clearance for a particular organ of elimination, for example, the hepatic clearance or the renal clearance, as the product of the extraction ratio and the blood flow to that organ, which is represented by the letter Q in this equation. If we analyze this equation, we notice that if the extraction ratio is high, so close to 1, clearance becomes dependent only on blood flow. On the other hand, if the extraction ratio is low, then clearance is quite sensitive to changes in its value, which means that clearance is sensitive to changes in the organ's intrinsic capacity to clear drug from the body. Conceptually, we can think of the extraction ratio as a conveyor belt in a production system that fills and corks bottles. There are two components to this production system: the filling of the bottle, which represents blood flow, and the corking of the bottle, which represents the extraction ratio or the organ's inherent capacity to clear the drug from plasma. If we have a high extraction ratio, this means that the capacity to cork the bottle far exceeds the rate at which the bottles are filled, and the system has an excess capacity to cork the bottles. Therefore, if the rate of bottle filling or the blood flow increases, so does the overall clearance, because the system has the capacity to handle the extra bottles. On the other hand, if we have a low extraction ratio system, the rate limiting step is the corking of the bottles. Therefore, if we increase the rate at which we fill the bottles, we do not have the capacity to cork them, and the filled bottles just start piling up. We therefore do not have the capacity to increase the overall clearance beyond the rate at which the bottles can be corked. So to summarize, drugs with a low extraction ratio, which is defined as a value of less than 0.2, are sensitive to changes in the organ's eliminating capacity, for example, enzyme induction or enzyme inhibition. But changes in blood flow to the eliminating organ do not lead to a change in overall clearance. Drugs with a low extraction ratio also have a high oral bioavailability, because as the blood with high drug concentrations from the gastrointestinal tract passes through the liver has a relatively low capacity to clear the blood of that drug. In the case of a high extraction ratio drug, the opposite is true. They have a low oral bioavailability because the liver has a high capacity to extract all the drug that is presented to it in the blood coming from the gastrointestinal tract. But these drugs are insensitive to moderate changes in the eliminating organ's metabolic or elimination activity, for example, once again, enzyme induction or inhibition, because there's a lot of excess capacity. But changes in blood flow, as can happen with, for example, cardiac failure or renal ischemia, does indeed result in a decrease in overall clearance for these drugs.